605 is divisible by 5. 130 is divisible by 10. 762 is divisible by 3. 212 is divisible by 2. And I can tell you all of that just by looking at those numbers. Positional notation, decimal numbers, base 10. I certainly have not memorized my times tables to that level. So how does that work? And of course, the first question somebody would ask is, why do we care? I'm not going to sit here and fuss about how useful something is in daily life. If you can't enjoy learning for the sake of learning, remembering that learning itself is useful as practice for thinking, then go back to watching PewDiePie. In the meantime, let's take a number. Let's do 615. So in positional notation, it's 6 times 10 to the 2 plus 1 times 10 to the 1 plus 5 times 10 to the 0. 10 to the 0 is 1, 10 to the 1 is 10, 10 to the 2 is 100. Hundreds place, tenths place, ones place. I can tell you right now that this number is divisible by 5 because the last digit is a 5 or a 0. So we divide by 5. What do we get? Well, what is 10, first of all, because we're going to have to divide this by 5 and this by 5 and this by 5. What is 10? 10 equals 2 times 5. Those are its prime factors. 10 is divisible by 5. So every single digit except the last one, because this has a 10, this has a 10. So this is divisible by 5. This is divisible by 5 regardless of what the digit is. So all we need to look at is the last digit. Well, what's divisible by 5? From the numbers 0 through 9, because that's our digit, 0 through 9. You can divide 0 or 5 by 5. And that's it. And thus, I can also say, what if this is a 4? And we want to divide by 2. Well, once again, 10 has a 2 in it. Well, 100 has a 2 in it, 10 has a 2 in it. So every single digit, except for the last one, is automatically divisible by 2. The last one, the digit, has to be divisible by 2, because 10 to the 0 is just 1. It's not doing anything. What digits are divisible by 2? 0, 2, 4, 6, 8. Every even number, all right? Every even number is divisible by 2. What about 10? Divide by 10. Well, we can divide 10 to the 2 by 10, 10 to the 1 by 10. Once again, every digit except the last one, because the base is 10. What about the last digit? How many digits are divisible by 10? Only one of them, a 0. If a number ends in 0, it is divisible by 10. Every number in any base is divisible by any factor of its base, or the base itself, if the last digit is divisible thus. Because if you divide by a factor of the base or the base itself, every digit except the last one has one or more of the base in it, so you can just divide that. And then all you have to worry about is the last digit. So that's the easy one. Now, the point of this video is not to show you divisibility tricks, because you Google that. There's no reason to sit up here and just go through a bunch of them, because go look on Wikipedia, go on some math is fun site, and then realize you're not going to use half of these. You know, I use 2, 10, 5, and 3 in daily life. And not really anything beyond that, because then I just use my calculator. So I'm just going to show you 3, because I like the number 3, and I just want to show you one of them. The point of this is to show you how you come up with some of these interesting tricks. So let's have a number, a 3-digit number, ABC, ABC. So if we had 342, A would be 3, B would be 4, C would be 2. Just a 3-digit number. Positional notation is A times 10 to the 2 plus B times 10 to the 1 plus C times 10 to the 0. Nice and easy. So we want to divide by 3. Well, it's not a factor of the base, so what do we do now? Let's write this out just so I can illustrate it. You can do it with powers and sums and whatever, with the, you know, the sigma or sigma notation, if you want to be completely abstract, but let me just demonstrate. So what do we have? We have 100 times A plus 10 times B plus 1 times C divided by 3. But what do we also have? This is 99 plus 1 times A plus 9 plus 1 times B plus 0 plus 1 times C divided by 3. So then we can write that out. 99 times A plus 9 times B plus B, and 0 times C, so we'll just say plus C, divided by 3. And we can distribute that as well. 99 over 3 times A over 3 plus 9 over 3 times B plus B over 3 plus C over 3. Let's simplify this out. We really have two pieces here. 99 over 3 times A plus 9 over 3 times B plus A plus B plus C over 3. 99 here, the 9 here, and then it's A, B, and C all divided by 3 is there. So this is the same number as we had before. We haven't done any division yet. We're just seeing if it is divisible. Well, 99 is divisible by 3. 9 is divisible by 3. In fact, no matter how many 9s you have, 9, 9, 9, 9, 9, da 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 da, it will always be divisible by 3. That should hopefully be obvious. 3 times 3 is 9, and so forth. So we know, for a fact, well, that's divisible by 3, and that's divisible by 3. So we have now a simple thing we can look at. Add the digits together. And if the digits summed together are divisible by 3, then there you go. I've known about this trick for all of my life since I was able to understand numbers and arithmetic, so I guess elementary school. I was taught, add the digits again until you get one digit. If it's divisible by 3, then the whole thing's divisible by 3. And it was just dark sorcery my whole life. And then eventually I'm like, wait, why? Get to that point and you say, stop, but why? And some teachers love that and some teachers hate that. Fortunately, I had the teachers who loved it and my parents loved it, so I got answers, and not like this. I was still too young to really go through all this nonsense, but I learned enough to realize that there's math there. Basically what I learned is it's not magic, there's math. The trick is we're just not doing the math outright. Somebody else has done the math and we're using their tricks. It's sort of like I have a hammer, but I didn't make the hammer, but I used the hammer. And then as I got older, I'm like, wait a minute, I need more. But now I have more knowledge. If you have 783, that is divisible by 3. 8 plus 3 is 11. Plus 7 is 18. 1 plus 8 is 9. That is divisible by 3. Let's do it out longhand. 3, 7, 83. Well, there's 2 times there, 6, 1, 18. 6 times 3 is 18. 3, 1. It's 261. How about 4,982? Is that divisible by 3? 9 and 9 is 18, so 17. 18, 19, 20, 21, 22, 23. 3 plus 2 is 5. It's not divisible by 3. But if I had just one more, it would be. So let's change this 4 to a 5. Let's just change this 4 to a 5. Now it's divisible by 3. Let's do it. 5982. 3, 5982. That's 1, 3, 2, 9. 9 times 3 is 27. 2, 8. 9 times 3 is 27. 1 is 12. 4 times 3 is 12. Let me even grab my calculator to confirm. 5982 divided by 3 is 1994. There is math there. It's hidden. It's secret. It's almost pre-computed for you because of the way positional notation encodes algebra. And so we can do tricks like this of adding the digits to see if a bigger number is divisible by something else, and it's black sorcery, but there you go. There are even funnier tricks. Like I said, go on Wikipedia and look some up. Gotta warn you though, I hope you know what modular arithmetic is. I do know what modular arithmetic is, and every time I see that symbol, I get the heebie-jeebies, because I know I'm in for a ride. Let me tell you, some of you might find it easy, and certainly the modulo operator in a programming language is easy, but modular arithmetic has a whole lot more going on than just that. So, anytime you see this, when you're doing math and you see this, go get a drink, you'll need it. But enough of that. I've sufficiently, hopefully, impressed you with how cool positional notation is and why we ended up developing it. So now you know what bases are and how they work and all the tricks thereof. The only thing left is how to convert between them. The easy answer is ask Google, but that doesn't give you an understanding. My next video will. Until then, I'll be seeing you.